So first, let's define what is central dogma. So the central dogma is the process by which the instructions of DNA are converted into the functional product. Do you know that Francis Crick proposed the central dogma? First proposed on 1958. Similar strategy is used for ourselves. The most important task for ourselves is to synthesize protein based on the codes of DNA. But how this codes read? What's the process decode this language? And a protein synthesized merely by the sequence of A, T, G, and C. The answer of the question lies in the central dogma of life. But again, what exactly is central dogma? Well, DNA makes a copy of itself by the process of replication, post-replication, and every cell decode of the DNA is cracked and transcribed into a messenger RNA. This mRNA is then read and the code is translated into protein. This interesting concept is nothing but the central dogma. We know that the replication process is semi-conservative in nature, so now our focus will be in two processes, namely transcription and translation. Let's begin in transcription. First, as we can see here, the process in which mRNA is synthesized based on the parent DNA template is called transcription. The part or segment of DNA encoding is a particular protein is called gene. So how a protein made from the sequence of base pair in the gene? Transcription. Protein are specific sequence of amino acids, so the various amino acids come together in a specific series to form a chain that makes up to the protein. But to get the amino acid in the series, we need to set up instruction. These are present in the form of mRNA. And where is the mRNA came from? It is synthesized by special template. Can you guess what the template is? That's right. The template is a gene. The template is a gene, so the segment of the DNA that encodes for the protein is copied first. The copy is in the form of the mRNA. This process of making mRNA is called transcription. Now, can you tell me why this process is needed? Well, it's quite simple. If there's no transcription, then how will mRNA be synthesized? And if not done, how will the protein be made? Hence, transcription is vital, but it's not easy as it is, since there are several enzymes and subsets involved in this process. They are referring to the step of opening of DNA double helix at specific point, assembling the set of enzyme, gathering of nucleotide, and so on. After all of these steps, an mRNA is found. The mRNA is like an exact copy of the DNA sequence that codes the protein. The only difference between the two, that mRNA is single-stranded and the base thymine replaced by uracil. Not that mRNA is ready, is all set into the cytoplasm. That is whereby the next step begins. It's the translation process. So let's take a look in this interesting process. So let's assume that the cell encounters set of instruction of performing a task, but the instruction is written in a coded language. All it means to do to translate this language and then perform the task. Any idea what is this process are we talking about? We are talking about the translation process. In the continuation with the process of transcription from the previous parts, let's now understand the next step of the central dogma of life. Translation needs converting into a simpler understanding form, and what get translating here the code hidden in the mRNA molecule. The process of transcription, copying the code from DNA that means it formed mRNA. Now, the mRNA comes out the nucleus to the nucleotide to cytoplasm, and here translation begins. To begin with, let's find out the directionality of this mRNA molecule. This is the 5' end and this is the 3' end. And how do we notice? We can recognize or notice this with a little help of the specific mucus. The 3' end or this 3' end has a continuation series in the nucleotides. This region is called 3' tail. The 5' end has a top of metal group, but why is the directionality needed? Wow, it's extremely important. The assembly that carries transcription binds to the mRNA near the 5' end. The assembly that we're referring to this is the ribosome unit. Two units of ribosomes. One is the small and two is the large unit. That helps in this process. Ribosomes are complex assembly which as molecular machine for protein synthesis. Remember the small dots attached to the rough endoplasmic reticulum. This area is to find the ribosome unit. So the ribosomes are usually made up of two subunits, a smaller and a large one. The smaller subunit binds to the mRNA and the larger subunit binds to the smaller unit and complete the assembly. Now, the other type of the mRNA is called tRNA. Steps in to get the remaining work done at the end of the chain of amino acid is found and released from the ribosome unit. The process of transcription and translation is called gene expression. The central dogma states that a pattern of information that occurs most frequently in our cell is from existing DNA to make new DNA replication, from DNA to make new RNA, from RNA to make new proteins. I'll show you the flow of information between DNA, RNA, and protein. Why is central dogma important? Central dogma is very important because it illustrates the genetic flow of information from DNA to RNA to protein. Why is there need to understand the process of central dogma? It's really need for us to understand the process of central dogma so that we can easily describe the genetic flow of information from DNA to RNA to protein.